All right, so now we're moving on to chapter 2, and we're now going to talk about evaluating indices. The chapter 2 that we are moving on is just called Indices. So our chapter 2 is called Indices, and you need to know what it means when I say indices, and that means something being raised to a power. And our first section we're going to focus on is just evaluating them, which means what will they be equal to if we have a number raised to a power, such as 2 to the third power. All right, so our first objective or goal is to be able to evaluate numbers raised to a power, just like I was saying exactly what this section is about. So 2 to the third power, -3 to the fifth power, or -3 to the fifth power. So you need to be able to evaluate, meaning what do these equal? And your second thing is you're going to have to know the difference between when we have -2 squared or -2 squared when one is in parentheses and one is not in parentheses. So the same thing here. What is the difference between this -3 to the fifth power and this -3 to the fifth power? All right, so it's very important that you understand the difference between those. And then the last thing, and we're going to cover this last, is we need to be able to rewrite a number as prime factors in index form. All right, so let's just go through this real quick. A number in prime factors. Well, when we talk about factors, we're talking about what numbers can we multiply to equal this. So, for instance, if we write 8, our factors are 2 and 4. However, we're talking about prime factors. So what are prime? What is prime? Prime numbers are numbers that can only be multiplied by 1 or has factors of 1 in itself. So 4 is not prime. It can be broken out by 2 and 2. And then index form means we're going to be writing it to a power. So we would need to be able to rewrite this 8. And we're multiplying 2 together 3 times. So we will be able to rewrite it as 2 cubed. All right, so that is something that we're going to be able to do. If I just lost you in that very beginning, don't worry about it because we're going to go through it more in depth later on. But I just wanted to go through this objective to kind of break out what it means. All right, so we often deal with numbers that are repeatedly multiplied together, and mathematicians use indices or exponents, they're interchangeable, to represent such products more easily. So if you recall in chapter 1, we talked about 3 plus 3 plus 3 plus 3, and we said that we can rewrite this as 3 times 4 in order for us to do this a little bit more easily, or in cases where we're using variables where we can combine them easier. Same thing goes with exponents. If we have 3 times 3 times 3 times 3, we don't want to rewrite this every single time like that. We want to rewrite it as something easier. And we can rewrite it as 3 to the fourth power. All right, so this is very important, this terminology that they're using over here. All right, so the first thing is the number that you're multiplying together. So in this case, we're multiplying 3 together. That is referred to as our base. All right, that's something that you'll need to know, not necessarily for this year as much, but in the future, you'll have to definitely know what is your base. And that's the number that we're multiplying together. And then however many times we're multiplying that number together, so in this case, we have 4 of them, that is referred to as our power, our index, or our exponent. All right, so it's very important for you to know this terminology, especially when we go to rewrite from index form to radical form. It's crucial for you. So make sure you know that the base is what we're multiplying together, and our power, our index, or exponent is how many we're multiplying together. All right, and just to talk about again, if n is a positive integer, so that's important, make sure you know it's positive. We will go through when our power is not positive anymore, when it's negative, and it changes. It makes us do something else. But if n is a positive integer, then a to the n is a product of n factors of a, meaning that if we have a to the n power, we are multiplying a together however many times it says. So whatever n is, that's the number of times that we're multiplying it together. All right, so just make sure that you know that a to the fifth power means we're multiplying a 5 times. A to the fourth power means we're multiplying a 4 times. All right, so now let's go ahead and evaluate some of these. So our letter A, we have 2 to the fifth power. All right, you can do this different ways. You may know some of these in your head. You may not know some of them. But what we can do first, if you're not sure, is rewrite it. 2 to the fifth power means we're multiplying 2 together 5 times. So 2 times 2 times 2 times 2 times 2. All right, then we need to actually go ahead and multiply this. So I'm just going to break this down. 2 times 2 I know is equal to 4. 2 times 2 I know is equal to 4. Well, 4 times 4 I know is 16, and I'm left with another 2 out here that I never multiplied. So then I would have 16 times 2 is then equal to 32. So 2 to the 5th power is 32. All right, our next example, this one's a little bit different. We have 2 cubed times 5 squared times 7. So that means this 2 cubed is first going to be 2 times 2 times 2. And then our 5 squared is going to be 5 times 5. And then it's going to just be multiplied by 7 at the end. All right, so first thing I'm going to do is just start multiplying some of my 2's together. So I'm going to multiply 2 times 2, that is 4. I'm going to multiply 5 times 5, that is 25. And now I have 4 times 25. So 4 times 25 is going to be equal to 100. And now I'm left with this 2 and this 7 I never multiplied. Well, 2 is easier to multiply, so I'm just going to go ahead and save it to multiply at the end. So I'm going to multiply it by 7 first. Well, 100 times 7 is going to be equal to 700. And now I multiply by that 7. And then the last one I need to multiply by is this 2, and that is equal to 1400. So this 2 cubed times 5 squared times 7 is 1400. Right, you can do this any way that you want. You don't have to do it in the shortcuts that I did where I only multiply part of them together. You can just keep multiplying down. But remember, you're not going to be able to use a calculator. So in some cases, it might be a little bit better for you to figure out a easier way of multiplying these. So for instance, I went and multiplied 2 by 2 to get 4, and then I multiplied a 5 by 5 to get 25. And then I knew that that was going to be equal to 100, which is why I then saved my 7 and 2 to be multiplied with last. But whatever method you feel most comfortable with is the one that you will need to use. Right, so far we've only worked with positive bases raised to a power. However, our base can also be negative. And to indicate this, we need to use brackets. So what I mean by that, and this is one of our objectives, I believe it was objective number 2. If I write negative 2 squared, this does not equal to negative 2 squared. All right, if our number is not in parentheses, that means that it is negative 1 times 2 squared. So it'll be negative 1 times 2 times 2, negative 1 times 4, or negative 4. When it's in parentheses, that means that entire number is being raised to the second power. So that means this is negative 2 times negative 2. And negative 2 times negative 2 we know is equal to 4. So as I was telling you, they are not equal to each other. So it is, I cannot tell you how many times mistakes are made because people see this negative 2 squared and then they automatically say it's going to be equal to 4. That's incorrect. Right? If it is not in parentheses, then it is not a negative number being squared, but we're squaring just a number next to the power. And then we're just multiplying it by negative 1 at the end. All right, so it's important for you to know the difference between these. All right, another thing that you guys need to know with negative bases is let's just go through all these negative 2's raised to the different powers I have. So negative 2 to the first power, anything to the first power is just itself because we're not multiplying it twice. We're not multiplying it together 3 times. It's just the number that we have. So negative 2 is equal to negative 2. Well, negative 2 squared, we know it's negative 2 times negative 2, and that's going to give us a positive 4 because negative times negative is positive. Negative 2 to the third power, well, we already know negative 2 times negative 2 is positive 4, and positive 4 times negative 2 is negative 8. Right? Then when we do negative 2 to the fourth power, well, we know negative 2 times negative 2 is 4, so we have negative 2 times negative 2, 4, and positive 4 times positive 4 is positive 16. Right? Negative 2 to the fifth power is equal to negative 32. So if you notice, our signs keep changing. Negative, positive, negative, positive, negative, positive. Or what you need to be able to identify is whenever our negative number is raised to an odd power, it is going to end up being a negative number, right? Because it is telling us that we will have one negative number left over that we will be multiplying at the end. Whenever we had an even power, our number was a positive number, right? So that is a rule when raising negative numbers to a power that you need to know. So as I just showed you, a negative base raised to an odd power is negative, and a negative base raised to an even power is positive. All right, so let's just go through a few examples. I'm going to skip C. So for A, we have negative 3 to the fourth power. So since the negative is included in parentheses, that means we are doing negative 3 times negative 3 4 times. All right, so now you are not going to be able to use a calculator, so you need to do this by hand. So I would suggest you do negative 3 times negative 3 is 9. So that means we know this negative 3 times negative 3 is also 9. 9 times 9 is equal to 81. And now we can go back and look. It is a negative number to an even power, so I know it's going to be positive. So I can just use some of these to check my work a little bit. All right, so my answer would then be 81. All right, so for the next one, for B, it is going to be negative 3 to the fourth power. Well, this is equal to negative 1 times 3 times 3 times 3 times 3. Well, we just solved for 3 to the fourth power is 81. So then this will be negative 1 times 81 or negative 81. See, the difference between this number here and this number here is the negative is included in our base because it's in parentheses, but it's not included here because it's not in parentheses. So that means just the 3 is being raised to a power. So even though this is an even power, this negative sign is not part of our base, so it's just going to be the negative of 3 to the fourth power. All right, and then the last one that we have, C, it said negative of negative 3 to the fifth power. Right, so then this is going to be equal to, let me just pause this for a second. All right, I realized that the video was getting long, so I just wanted to rewrite this so that way you don't have to watch me write negative 3 multiplied 5 times. All right, but since this is in parentheses, that means a negative 3 is included in our base. And we already did negative 3 to the fourth power, we know is then equal to 81. So we're left with negative 1 times 81 times negative 3. All right, negative 3 times 81 is going to give us a negative 243. And it's still being multiplied by the negative 1 out front, so it's going to give us a positive 243 as our answer. All right, so even though we see it's a negative base and an odd power, we know that that is going to end up giving us a negative number at the very end, which it did. But then we're multiplying it by a negative 1 at the end. So it does give us a positive 243. All right, so I believe there's one more example, and then we're done with this video. All right, so the last thing that we have to do is we have to write a number, in this case 504, as a product, meaning multiplying prime factors, so numbers that are only divisible by 1 in itself, in index form, meaning raised to a power. So the way I'm going to suggest you do this is to make a factor tree. All right, so we're only using the numbers 2, 3, 5, and 7. Actually, no, I cut off the directions. It did say ... so that means use any of the other prime numbers. So any prime number that goes into it, we're going to use. So the first thing that we're going to do is to start dividing. So look to see, do any prime numbers go into this? Well, I see it's an even, so I know 2 can go into it. 2 goes into 50 25 times, and 2 goes into 4 twice. So I'm left with 252. Once you get a prime number that goes into it, circle it, because that's something that we're going to have to use later on. All right, I know 2 can go into 252, and it goes into 126 times. So once again, I have a prime factor. Let me circle it in the same color. So we're going to circle it. So that lets me know I have another prime number 2. It's divisible by 2. However, I know 3 goes into 12, and I know 3 goes into 6. So I'm going to divide this one by 3 this time. So 3 goes into 12 4, 3 goes into 6 twice. So again, I have another prime base. All right, then I look and see 42, I know that 2 goes into 42. So 2 goes into 42 21 times. So here's another prime base. And then the last one I see 21. Well, I know 3 goes into 21 7 times. Both of these numbers are prime. So what we do then is we write out all the individual prime numbers that we have. So we have 2 times 3 times 7. All right, because I had 2, I had 3, and I had 7. So those are my unique prime numbers I left over. And then I count however many I have. Well, I have 1, 2, 2, 3, 2. So that means 2 needs to be raised to the third power. I have 1, 2, 3. So that means 3 needs to be raised to the second power. And then I only have 1, 7. I do not need to write the power of 1 because when there's no power written, it's understood to be 1. All right, that is it for this video.